Overloading and templates. This video covers operator overloading and templates. Templates enable the programmer to write generic code for related functions and classes. We will also simplify overloading through the use of templates called template functions. Hopefully by the end of this video you will learn about overloading. You will become familiar with the restrictions on operator overloading. You will examine the pointer this. You will learn how to overload operators as members and non-members of a class. You will discover how to overload various operators. You will become familiar with the requirements of class with pointer member variables. And also you will learn about templates. And finally, you will explore how to construct function templates and class templates. Let's talk about why operator overloading is needed. Consider these two statements. The first statement declares myClock to be an object of type clockType and initializes the member variables hour, minute, and second of myClock to 8, 23, and 34. The second statement actually respectively creates a your clock and initializes that to 4, 5, and 30 for hour, minute, and seconds. Now, consider these two following sets of statements. First, let's take a look at this one. The first statement prints the value of myClock in the form of hour, minute, and second, while the second statement increments the value of myClock by 1 second, and then the third statement checks whether the value of myClock is the same as the value of your clock, and so on and so forth. These statements do the job. However, if we can use the insertion operator in order to output the value of myClock, the increment operator to increment the value of myClock by 1 second, and relational operators for comparison, we can enhance the flexibility of class clockType considerably. More specifically, we prefer to use this type of statements. Recall that the only built-in operations on classes are the assignment operator and the member selection operator. Therefore, other operators cannot be directly applied to class objects by default. However, C++ allows the programmer to extend the definitions of operators such as relational operators, arithmetic operators, the insertion operator for data output, and the extraction operator for data input, so that they can be applied to these classes. In C++ terminology, this is called operator overloading. Recall how the arithmetic operator division works. If both operands of division are integers, the result is going to be an integer. Otherwise, the result is a floating point number. So in our example, if you look at these two results, which are integer, 5 and 2, when we divide 5 by 2, the result down here is going to be an integer, which is 2. But if I divide integer 5 by float 2, which happens in this line, the result now is 2.5. As you can notice, this actually means the division operator has one definition when both operands are integer and another when an operand is a floating point number. Which definition is used actually depends on the data types of the operand it is being used with. Similarly, the stream insertion operator and the stream extraction operator could be overloaded. The extraction operator is used as both a stream extraction operator and a right shift operator. The same way, the insertion operator is used for both stream insertion operator and a left shift operator. These are just examples of how these operators are actually overloaded. Other examples of overloaded operators are plus or minus. The result of addition or subtractions are different for integer arithmetic, floating point arithmetic, and pointer arithmetic. C++ allows the user to overload most of the operators so that the operators can work effectively in a specific application. It does not, though, allow the user to create new operators. Most of the existing operators can be overloaded to manipulate the class objects. In order to overload an operator, you must write function or functions, that is the header and the body, to define what operation the overloaded operator indicates should be performed. The name of the function that overloads an operator is the reserved word operator followed by the operator to be overloaded. The result of an operation is a value. Therefore, the operator function is a value returning function. Look at the syntax of the heading for an operator function. In C++, operator is a reserved word. Recall that the only built-in operations on classes are assignments and member selections. To use other operators on class objects, they must be explicitly overloaded. Operator overloading provides the same concise expression for user-defined data types as it is for the built-in data types. To overload an operator for a class, first include the statement to declare the function prototype to overload the operator, which is the operator function in the definition of the class. Then write definition of the operator function. Certain rules must be followed when you include an operator function in a class definition. These rules are described here in this video, and we call them operator functions as member functions and non-member functions. The result of an operation is a value. Therefore, the operator function is a value returning function. Look at the syntax of the heading for an operator function. In C++, operator is a reserved word. Recall that the only built-in operations on classes are assignments and member selections. To use other operators on class objects, they must be explicitly overloaded. Operator overloading provides the same concise expression for user-defined data types as it is for the built-in data types. To overload an operator for a class, first include the statement to declare the function prototype to overload the operator, which is the operator function in the definition of the class. Then write definition of the operator function. Certain rules must be followed when you include an operator function in a class definition. When overloading an operator, keep the following in mind. You cannot change the precedence of an operator. The associativity also cannot be changed. For example, the associativity of the arithmetic operator addition is from left to right, and it cannot be changed. Default parameters cannot be used with an overloaded operator. You cannot change the number of parameters an operator takes. You cannot create new operators. Only existing operators can be overloaded. The operators that cannot be overloaded at all are dot, dot star, colon colon, question mark colon, and size of. The meaning of how an operator works with built-in types, such as integer, remains the same. That is, you cannot redefine how operators work with built-in data types. And finally, operators can be overloaded either for objects of a user-defined types or for a combination of objects of the user-defined type and objects of the built-in types. At the beginning of this video, I remarked that if we can overload various operators for class, then we can increase the flexibility of the class. Now that we know the syntax to overload an operator for a class and certain restrictions on operator overloading, let's have a practice and see how actually we can overload an operator. For this example, I'm actually overloading the operator equals to within the class clock type. So the prototype of the function to overload the equality operator for the class is going to be like this. We have a return value of bool, we use the keyboard operator, and then the operator sign, and then we pass the object of the class to it as a reference. This statement must be included in the definition of class clock type, which it is. As you can see, this is the scope of the class, and the statement that line none is actually included within the definition. For the next step, I would like to actually write the definition of class operator equality, which is going to be like this. So notice what we do here. So basically, I'm just defining the prototype over here. As you can notice, this line and this line have the identical signature on the top. And then what I'm returning is the result of evaluation between minutes, hours, and seconds. Look what it does. It checks the hour of current object with the hour of other object, and it evaluates between minutes of other object and the current, and the seconds of current object and the seconds of the other clock. And if all of these are true, because we are using AND, notice that the condition in between is AND. If all three are equal, then it returns true, and therefore we can consider that the other clock, which we are passing over here, is equal to the current clock that we are looking at. Now let's write the code and test our program. Okay, so I want to create a couple of clocks, my clock, your clock, and temp clock from this class first. I'm calling the constructor and setting my clock to 8:23:50, setting your clock to 8:23:50. So obviously you can guess that I want to check them for equality later down the road, and a temp clock set to 9:16 and 25. Now let's do the comparison. So the code we generated checks my clock against your clock, and notice that we are just using the simple operator of equality over here, and we say, okay, if they are equal, then print the clocks are the same, and if they are not equal, print the clocks are different. Now let's run this program and see what happens, and as you can see, the message is the clocks are the same. So what happens is this line is checking them and obviously figures out that these two are the same. So what I'm going to do is I'm going to change this to 40. So now the second is different, and I'm going to run it again, and as you can see, the result is the clocks are different. So overloading other simple operators like plus, minus, or the Boolean operator like greater than or less than follows the same pattern. There's only the insertion and extraction operators that is a bit different, so let's go ahead and talk about those a little bit. Before you actually start doing overloading the stream insertion operators in C++, you should remember that cout is an object of output stream class, and cin is an object of input stream class. So when you define the data types, those data types should be of OStream or iStream. Also remember that these operators must be overloaded as a global function, and if we want to allow them to access private data members of the class, we must make them friend. So they cannot be defined within the class, they have to be globally defined, and therefore you have to make them a friend of a class. In operator overloading, if an operator is overloaded as a member, then it must be a member of the object on left side of the operator. For example, consider the statement OB1 plus OB2. To make this a statement compile, we must overload plus in the class of object1 or make plus a global function. For that reason, when we are overloading the operators of insertion and extraction, basically we have to define them within the class of C, the class that C out comes from, if we want to define it as a member function. This is not a good option most of the time because we don't want to go to the standard namespace and change anything in there. Therefore, these operators are overloaded as a global function with two parameters, cout and object of the user defined class. Let's go to the code and see this actually in action. Let me first introduce the prototypes of the both operator overloading functions within our class. Okay, for the output, I am friending this function over here with this class. So remember, the keyword friend within this function explicitly grants friendship to this function, okay? And the data type, as I said, is going to be output stream, and it comes from the namespace standard, same as the data type being iStream from the namespace standard when you have the insertion extraction for the input. Okay, so for the insertion we go output stream, for the extraction we go input stream, and of course it needs two operands. The first is going to be an output type from the output stream, and the second operand is going to be a clock from the type clock type, which we're passing it by reference. And notice that over here I set this to be constant because the only thing this operator is supposed to do is to show something on the display and should not be able to change anything for this object which is passed by reference. If you remember, when you pass by reference, the object is fully available to the function, and function can accidentally or intentionally change that object, and that's why I'm putting the keyword constant here to make sure this object which is being passed by reference is safe and secure. While for the extraction, because I'm extracting something from the command line and put it in the object of the clock type, I don't have the keyword constant, so user can actually enter information and save it over there. So now is the time to go ahead and define these prototypes in my program. So what I'm going to do is I'm going to come down here right after where I defined the overloaded operator of equality, and will define the overloaded definition for these two operators. And here are the definitions. So let's go through those and see how actually they are defined. So for the output insertion operator, first of all, notice that line 30 has the exact same signature as what you see over here. And the other difference that I want you to notice is between line 27 and line 30. On line 27, we defined equality as a member operator of class clock type. But insertion and extraction operators are not defined as a member of class clock type. They're just defined global. It is very important. That's the critical difference, as I talked about a couple of minutes ago. So we just friend them with the class and define them globally, not as a type of the class. So let's see what we have here. For the output stream, I'm using the out and an object of class C. And notice all that I do within this function is I am forming the output stream. So output stream is being formed to have some literals and some variables set to it. In this case, I'm setting the hour here, minute, and second within a bunch of literals that they read that the current time on your clock is hours and minutes and seconds. And then when I'm done with setting this up, I'm just returning the output stream. Okay, so the cout is actually happening over here when I return it. For the input, what I'm doing is I am basically defining the input stream, or cin over here, to enter the hours, minutes, and seconds for me, while I'm actually showing a proper message to user beforehand. I suggest you to take a moment, pause the video, and study lines 27 to 43 and make sure you have a full understanding on how these are defined and what is actually happening. Okay, now let's take a look at how we actually will use these. So the only two lines that I added after defining the overloaded operators are lines 60 and 61, in which, as you can see, I'm basically getting temp clock from the user with simple command of cin temp clock, and then showing it with the simple command of cout temp clock. Look at how easy is the job when you overload the operators. If you didn't have this operator overloaded, for every clock you needed to show, you needed to create the stream from scratch and show it. Or for entering any clock, you actually needed to enter the hour, enter the minutes, enter the seconds, and these could have been different lines which are being repeated multiple times and therefore making you more prone to the errors. So let's run the program and see what happens. As you know, this line comes from our previous example, but look what the cin does. So basically this is the result of running line 60. Line 60 calls the cin on temp clock, and when you call the cin with the extraction operator, because extraction operator is overloaded, look at it, it is overloaded here. This is what's going to be called, this one, and therefore you see this message, please enter your clock here. Okay, so let's go and answer these questions. So let's say the clock is 2, and then it asks for the minutes, I say 5, and then it asks for the second, and I say, let's say 45 seconds. When I hit enter, line 61 is going to be run, and when it runs, it's actually coming back over here and creating this stream and returning it back to you. So as you can see, all that happened through just two simple cins and couts that you run on a complex object. The fact that you can use normal operators that are meant to work for primitive data type and simple data types with any type of complex objects through concept of operator overloading makes your program very powerful, and your main, as you can see, can turn into a very simple place to just use operators to do any type of calculation or operation you need on your objects. And with that, I think it is good enough right now for the operator overloading. Of course, you can practice and take advantage of this code as your reference and go ahead and overload like the addition operator or the subtraction operator and see it in action. See if you can do clock 1 minus clock 2 or my clock minus your clock, and within that just make sure the seconds are being subtracted or just the hours are being subtracted, and also you can show some message or anything. So the limit is the sky, so you can go as far as your creativity and problem solving skills can go. Now let's talk a little bit about the pointer this. A member function of a class can directly access the member variables of a given object of that class. Sometimes it is necessary for a member function to refer to the object as a whole, rather than the object's individual member variables. How do you refer to the objects as a whole, that is a single unit in the definition of member function, especially when the object is not passed as a parameter? So the answer is every object of a class maintains a hidden pointer to itself. And the name of this pointer is this. In C++, this is a reserved word. The pointer this and the member function is available for you to use. When an object invokes a member function, the member function references the pointer this of the object. Let's go back to our code and actually try using pointer this. Let me just clean this up pretty quick. Okay, so we go back to the class clock type, and we want to define a function over here that actually just subtracts 2 minutes from the minutes and 2 seconds from the seconds and returns the value. So let's develop the code for that. Okay, here it is. So what I did was I created a new function named reduce minutes and second by 2. And notice that the return value of that function is from the class type, so that is clock type. And what happens within this class is minute is going to be decreased by 2, and then second is going to be decreased by 2. But notice how I return this object. So basically what I'm doing is I'm returning the dereferenced object of this pointer back to the object. So whatever object this function works on, it basically reduces the minutes and seconds of that function. And this over here is referring back to it. Now let's go to our main down here and try it on any of these things. So let's do this. Let's call your clock, which we played with it before. And what we want to do is we want to call the function reduce minutes and seconds by 2 over it. So what you expect from your clock after the fact is it's going to be 8, 20 minutes, and 38 seconds. And down here, what I'm going to do is I'm going to go up here and just simply do a cout of your clock. Okay, so we're going to see the your clock, and let's run it pretty quick. So I'm running it now, and as you can see, the current time on your clock is going to be 8 hours and 21 minutes, which is minus 2 out of 23, and 38 seconds, which is minus 2 out of 40. Also, again, notice how life is easy when you have overloaded operators and you simply just put it in. Within the same process, you can actually do whatever you want on the object. So that's how the operator this over here is helping us having access to a reference to the object itself within the class. So if you need to do something on the very same object of the class, you don't need the object to be passed. You can just use this pointer and take care of any function that you want to take care of. Now that we learned about pointer this, let's talk about overloading unary operators. The process of overloading unary operators is very similar to the process of overloading binary operators. The only difference is that in case of binary operators, the operator has 2 operands, and in the case of a unary operator, the operator has only 1 parameter. Therefore, to overload a unary operator for a class, you first need to look at the operator, and if the operator function is a member of the class, then it has no parameters. And then if the operator function is a non-member, that is a friend function of the class, then it has only 1 parameter. Next, let's take a look at how we overload the increment and decrement operators. The increment operator has 2 forms. One is the pre-increment, like ++x, and the other one is post-increment, which is x++. So in both of them, x is a variable, say of type integer or anything. In the case of pre-increment or ++x, the value of the variable x is incremented by 1 before the value of x is used in an expression. In the case of post-increment, the value of x is used in the expression before it is incremented by 1. So, let's look at overloading the pre-increment operator. Overloading the pre-increment operator is quite straightforward. In the function definition, first we increment the value of the object, and then we use the pointer this to return object's value. For example, suppose that we overload the pre-increment operator for the class rectangle type to increment the length and width of a rectangle by 1. Also, suppose that the operator function operator ++ is a member of class rectangle type. The operator function ++ then has no parameters, and we use the pointer this to return the incremented value of this object. So pretty basic. When we do that overloading, we just return the value which is incremented by 1. This increment could be of anything. For example, within this operator plus plus, you can have length plus plus, or you can have width plus plus, or both of them. That is your decision. However you want to implement that increment, and then basically just return the object. If you want to define it as a non-member function, then in that case, within the class, the function prototype must be introduced as a friend, same as you noticed before. So, general syntax to overload the post increment operator plus plus as a member function is as you can see. So, within the class, we define the operator plus plus as a member, and outside, we basically create a temp, put the information of this object in the temp. So, basically, we use this pointer to copy the value of the object. Then we're going to increment the object, and then we're going to return the temp value. As you know, this is how the operator plus plus works when it is in the increment or the decrement position. So the syntax to overload the post increment operator plus plus as a non-member function is as such. As you can see, again, within the class we need to friend it. Then outside the class we create a temp object, put the incoming object into it, and then increment it, and then return the result of it out. Previously, when we talked about shallow and deep copies, we actually described the peculiarities of classes with pointer member variables. Now that we have discussed how to overload various operators, let us review the peculiarity of classes with pointer member variables for the sake of completeness and how to avoid them. Recall that only built-in operations on classes are assignment and member selection. The assignment operator provides a member-wise copy of the data. That is, the member variable of an object are copied into the corresponding member variables of another object of the same type. We have seen that this member-wise copy does not work well for classes with pointer member variables. Other problems that may arise with classes with pointer member variables relate to deallocating dynamic memory when an object goes out of the scope and passing a class object as a parameter by value. To resolve the problem, classes with pointer member variables must explicitly overload the assignment operator, include the copy constructor, and include the destructor. Recall that the function to overload the operator subscript for a class must be a member of the class. Furthermore, because an array can be declared as constant or non-constant, we need to overload the operator subscript to handle both cases. The syntax to declare the operator function operator subscript as a member of a class for non-constant array is type address operator subscript, and then you pass integer index to it. The syntax to declare the operator function operator as a member of a class for constant arrays is constant type as an address and operator subscript, where we pass the index integer to it, and of course the keyword constant. In this case, the type is the data type of the array elements. So far we discussed operator overloading. Operator overloading provides the programmer with the same concise notation for user-defined data types as the operator has for built-in types. The types of parameters used with the operator determine the action to take. Similar to operator overloading, C++ allows the programmer to overload a function name. Recall that a class can have more than one constructor, but all constructors of a class have the same name, which is the name of the class. This is an example of overloading a function. Further, recall that overloading a function refers to having several functions with the same name but different parameter lists. The parameter list determines which function will be executed. For function overloading to work, we must give the definition of each function. Let's look at a very simple example here to demonstrate the function overloading. If you look at this program on line 5, you're going to find the function named print. And this function accepts an integer, which simply writes down here is the integer with the result. And then we have the same function name. Notice they both have the name print, okay? And this time, instead of passing integers to it, we pass doubles to it. And in this case, we simply see out here is the float f. And then another one is built for the characters. Now look at the main. Within the main, if I call the print with different type of data, you will see that the compiler will automatically yield the correct related function. Meaning, if I run this print 10, which is on line 16, because 10 is an integer and between these three, line 5 has the print function that accepts integer, this line will be executed. In case of 10 and 10, because this is a float, this one will be executed, which is related to the input of float. And in the same way, for 10, I'm expecting this line to be executed. Let's run this program and look at the output. As you can see, here is integer 10, which is obviously this line. Here is float 10.0, which is this line because of the literal. And then here is the character pointer 10, which basically is calling this line for us. So function overloading is very simple. Having same name with different type of data that we pass to it gives us a huge flexibility in the main, because we don't need to be worried about how this thing is being handled, because it is already handled before within the respective overloaded function. So now let's go back and talk about templates. Templates are a very powerful feature of C++. They allow you to write a single code segment for a set of related functions called a function template, and for a set of related classes called a class template. The syntax we use for template is template, class type, and then declaration. Type is the name of data type, built-in or user-defined. And declaration is either a function declaration or class declaration. In C++, template is a reserved word. The word class in the heading refers to any user-defined type or built-in type. The word type is referred to as a formal parameter to the template. Note that in the first line, template class type, keyword class can be replaced with the keyword type name. Similar to variables being parameters to functions, types that are actually data types are parameters to templates. Like function templates, class templates are used to write a single code segment for a set of related classes. Class templates are called parameterized types because based on a parameter type, a specific class is generated. A template instantiation can be created with either a built-in or user-defined type. The function members of a class templates are considered to be function templates. Until now, we have placed the definition of classes in the header file and the definition of member functions in the implementation file in separate files. The object code was generated from the implementation file and linked with the user code. However, this mechanism of separating the class definition and definitions of the member functions does not work with class templates. Passing parameters to a function has an effect at runtime, whereas passing parameters to class template has an effect at compile time. Because actual parameter to a class is specified in user code, and because the compiler cannot instantiate a function template without the actual parameter to the template, we can no longer compile the implementation file independently of the user code. This problem has several possible solutions. We could put the class definition and the definitions of the function templates directly in the client code, or we could put the class definitions and the definitions of function templates together in the same header file. Another alternative is to put the class definition and the definitions of the functions in separate files as usual, but include a directive to the implementation file at the end of the header file. In either case, the function definitions and the client code are compiled together. For illustrative purposes, we will put the class definition and the function definition in the same header file. Okay, let's summarize. An operator that has different meanings with different data types is said to be overloaded. An operator function is a function that overloads an operator. Operator is a reserved word. Operator functions are value returning. Operator overloading provides the same concise notation for user-defined data types as for built-in data types. Only existing operators can be overloaded. The pointer this refers to the object. A friend function is a non-member function of a class. If an operator function is a member of a class, the leftmost operand of the operator must be a class object or a reference to a class object of that operator's class. Classes with pointer variables must overload the assignment operator and include both a copy constructor and a deconstructor. Templates. Function template, a single code segment for a set of related functions. Class template, a single code segment for a set of related classes. These are all called parameterized types. Okay, and this is it for this video.